Hello, and thank you for joining us today for our webinar on TSDD, Shifting Security Left Through Test and Security Driven Development. I'm Hayley Menzies, Product Marketing Manager at Kiuwan and Preemptive, and I'm excited to introduce today's session. So, Test and Security Driven Development, or TSDD, is a DevSecOps strategy that enables faster, more secure releases with higher quality. Today, we'll explore how to apply TSDD and potentially shippable increments to seamlessly integrate security throughout your SDLC. And with that, I'm excited to introduce to you today our first expert. Chris Faraglia is a seasoned software engineer and technical product manager with expertise in QA and testing across regulated industries like nuclear power and healthcare. And our second expert in today's session, John Brawner. John is a software development expert with a strong background in .NET and Java. He has held roles in infrastructure development, sales engineering, and director of support roles. Welcome, John, and welcome, Chris. In saying that, I will hand it over to Chris to kick us off for today's session.
Excellent. Thank you so much, Haley. Welcome, everybody. Yeah, great topic today. So we'll jump right in it and get into kind of our first section. We talk about release agility, PIs, and fast flow. So before we go in, and I want to talk about really some of the challenges, and I'm sure a lot of people on the call can relate to this, of being agile when releasing software. And I'm not really talking about agile as in a development methodology, but agile in terms of patterns and problems that really impact our release timelines and quality for getting that level of release agility to deliver fast and frequent releases. One of the areas we look at that is really an impact, right? Testing prior to releases a lot of times is like an anti-pattern. Is done when features are really fully integrated rather than during development, right? So we're really doing a lot of testing at the very tail end. We're not being proactive and really embracing the shift left concept. What happens, right? We have a lot of times that these approaches yield problems at the tail end of the cycle, and they cause these impacts to both release quality, timelines, delays, fixes, last minute changes. And this obviously impacts our release agility, timelines. This also can relate to the same practice around security scanning. And I know John will go into a lot of detail, so I won't go into too much. But security scanning and analysis done too late in the same way of testing can yield the same type of issues. We find security vulnerabilities. We look at issues that we want or need to remediate due to compliance that we didn't realize early in the cycle. And now, again, we're going into patterns in this kind of problem where we're pushing timelines, where we're sacrificing on security, or in this case, quality overall. And then really the last thing here is talking about just feature scope, right? Maybe we're adding or changing scope for what needs to be delivered or reacting to the market or our customers. And to do that, whenever we're doing these activities, instead of shifting left, we're actually shifting right. It becomes very hard to be release agile in terms of how frequent, fast, on time, and high quality and security factor into what we're doing in terms of delivering software. So these three areas are really core, what I would think, problems and patterns that impact release timelines and quality. And we'll see how we can really overcome a lot of these areas with this TSDD concept as we talk more. So one of the areas I'd like to talk about is using program increments. And for those of you that are agile, SAFe certified or more agile practitioners, you may have heard of this. Again, this is an agile SAFe kind of practice that at a very high level, and I won't go too deep in it, but basically looks at breaking down roughly 8 to 12 week increments where we are actually going to deliver very high value incremental iterations for software targeting features that we want to deliver. Whenever we do this, this is a really important approach, and I think anybody can take away from this, whether you're operating in an agile SAFe environment or you're some hybrid flow, even from a waterfall scoping perspective. This really starts to enable organizations by providing these structured cycles to adjust priorities so we can get in the activities we need to, right? And what I mean by that is it boosts release agility by having us focus on testing and security early and planning and identifying that 8 to 12 week cycle or a time box period. How much can we really fit in to get all of the required activities, including our software testing and security practices, as part of the actual deliverable. And then the last thing here is really predictable delivery. So if we chunk these type of activities and include them rather than thinking them as an afterthought, meaning we have a set of work, when that work is done, then we go and test and then we security scan. We do this as part of a single unit of work or a planned program increment in this case. We now have more manageable PIs. We have more predictability. We can track progress and adapt through that for the total body of work that we need to do to deliver. So this kind of comes to our next topic and why this concept of shift left is important. For those that have probably been in some of our previous webinars from the Testro product, we talk about shift left in terms of testing, but I'm really talking about it in terms of both testing and security practices. And John will dive deep into the security side here in a moment. But it really means, at a very high level, moving activities earlier in the development cycle so we can then address changes and act sooner. If we wait to the right, we're running out of time, bandwidth, and usually the opportunity to meet deadlines or maintain quality standard. We're going to be sacrificing. So it moves it earlier in the cycle and is part of our overall release plan or our program increment, if you're going to define that, like we just talked about. Developers and testers get to work more closely from the start. This really promotes this concept of more shared responsibility than traditional throw it over the fence mentality of when the development's done, then we do testing, then we security scan prior to releasing the product. We start to collaborate and get this synergy early, and the shared responsibility actually defines issues and gets more strategy if we do have to change our scoping or our approach to get the release to meet the deadlines, requirements, security compliance, or even defects that are identified in the process. And then lastly here, relating to defects, this minimizes costly fixes later, improving overall efficiency for what we're going to do for how we're going to deliver. A defect that we catch in early sprints in a release or early in a given PI has a much better chance of being fixed correctly and not impacting both resourcing, timelines, or breaking other code versus doing it late in the cycle, unplanned, and potentially blowing timelines, or going unfixed and taking an at-risk release. So all these concepts really start building when we talk about PIs and how we identify really time box or structured bodies of work that we are going to use that comprise our release. Embedding our testing and security practices, realizing shift left is not something that's nice to have, but it's required to have if we're going to start to kind of meet these requirements and release agility goals that we want to have. Timelines, low defects, very secure software and code, be able to do that at a very high level multiple times throughout a cycle. How does this relate to all of those concepts? So this is really more of a high level, more of a lean practice, is fast flow. Fast flow, and I like the picture we show here, is really representative of what fast flow is meant to do. It's meant to keep things flowing and moving, removing barriers, delays, automating tasks, and getting quick feedback. Because the faster we get feedback on things that we need to do or wrong, change, or add, the quicker we can adapt to the essentially the actual release goals that we're going to achieve. So if we know we have defects, we know which ones we can fix and which ones we can't, we can make product changes. If we have bugs related to security, we can make changes and remediate those prior to release. So the more we can be agile in terms of this, this is something that's really important. So for testing, executing tests not just after, but before, during, and after features are developed really embodies this concept of really test-driven development. People a lot of times ask, how can I execute or create tests before the features are done? Test-driven development, we'll get into in a moment, essentially gives us a framework to expect tests to fail, which are then later satisfied as features are implemented as a validation mechanism for what we're changing in our software. From a security perspective, really means early and proactive security scanning, looking at threat modeling and overall awareness of everything we're using, including third-party libraries. And I know John will give more of a deep dive on all these. But really, it comes down to this concept of DevSecOps, right? Development, security, in operations, not doing it at the end, not even just doing it at the beginning, but throughout the entire cycle, but starting it on that left side. So I'm going to get into some concepts specifically focused to the TDD, or the test-driven development side. And I'm also going to look at some examples to kind of drive this home. First off, I want to talk a little bit about how does TDD actually relate to security? You know, traditionally we talk about TDD for functional testing, or maybe more commonly unit level testing. But TDD actually provides an approach where we write tests before code or a feature is implemented, ensuring the code or the change actually meets requirements. So how can we actually do this in terms of security? One of the areas here that I think it lends itself really well is security has very known, I'll say, structured patterns or vulnerabilities that are well documented and managed. One of which, if you look to the right, the OWASP top 10, a lot of people are familiar if you're more attuned to the like security space. But really, it talks about various patterns and vulnerabilities that are the top ones affecting the communities for development and organizations. The number one from the last revision is broken access controls. And this really touches on the idea that we need to ensure the access control mechanisms that we know we're putting into place actually function and work just like we would expect them to. So really, in the end of the day, it's not a security test. It's actually a functional, or even could be a unit level test for what we're trying to validate. So focusing on specific attack vectors for functional validation is something that is absolutely possible and we should be thinking about. One of the areas I'll talk about here in a moment is looking at a simple REST service, how we expect that to deny access when an expired token is used, related to some basic OAuth or basic authentication flows, depending on how the service is configured and what the end users are using. Auth-N and Auth-Z are a very common way that we can implement TDD at a unit, even a functional or integration level related to security. So how does this whole idea of security-focused TDD work? Okay, I'll kind of give you the roadmap or the checklist, if you will. Teams approach TDD very differently, but an example I want to talk about here is one, again, that I mentioned related to a REST service that uses basic authentication. This specific one targets this idea of broken access controls, so it's a great example and it's really simple. Here's how an approach could work around how we could do TDD for a given REST service for getting some testing done early, even before changes or the service has been implemented, or maybe a change to an existing service. So we would go and review requirements for a given service to be built or updated, identify to the development team what the changes are going to be and understand the scope. We're going to identify, in this case, what security-focused scenarios we know should pass once this REST service is completed, or in this case, maybe even modified. We're going to implement these test scenarios, and we're now going to ensure passing results once the code is actually implemented, right? So we're going to run it maybe before, and our passing results before the code is implemented likely are going to be some level of failure or error message. Once we implement the changes for the REST service and deploy it, get it in environments that we know are valid, we're going to then ensure passing results, which ideally should be passing, or maybe a 200 response or a certain payload. So we should see that shift from a undesirable or failure state switching to a passing state, focused on these security attributes specifically to the service that we're executing. And then obviously we're going to rerun these test cases and ensure passing results throughout development. And ideally, these become part of an ongoing regression or automation suite. So what does this really look like in real practice, right? I like to be very high level when we introduce concepts, but I think it's really important to say, how does this really look and work? So maybe we have a service that's a logon service that actually is an HTTP post action that logs in a user credential as part of a UI-based login form. This provides some credentials like username and password, email, first name, gender, and it also provides a mechanism for authentication using basic authentication. So you'll notice here, if we have expired credentials, maybe the user has changed their password and the base 64 encoded credential that we use for the basic auth is now expired or no longer valid. We should ensure that we're doing negative testing here to check what the expected response code is, the response message, and has attributes here for a specific user that should not show up. So this is more a negative focused kind of TDD driven test that we're doing functional testing to ensure we're working from a security perspective for expired credentials, that we're not gaining access to user credentials or login when we have expired credentials. This also could be a regression test related to the change that I just described in this specific example, which is using Postman, by the way, in a BDD format. So I'll go ahead and turn it over to John to give us more of a deep dive around all these security attributes and concepts.
Thanks, Chris. Chris has touched on DevSecOps, the concept of DevSecOps. So I just want to take a second to step back and go do an overview of a little bit more about what DevSecOps is, what it represents. And really, DevSecOps is about integrating security into our software development lifecycle without sacrificing speed and time to delivery. And really, it encompasses people, process, tooling. You always think of people, process, tooling. We talk about people, we're primarily, that primarily involves establishing responsible parties within our organization. Who's running the AppSec program? Who's responsible for the legalities around handling of customer data? Who's handling incident response, disaster recovery? We need dedicated energy behind these critical functions. That being said, building secure apps is not possible without everybody doing their part within their respective role. And kind of like Chris touched on earlier about creating that culture of security within our organization, as opposed to just trying to force policies from top down. With process, we've got things like setting goals, risk assessment, threat modeling, secure coding reviews. So what is the success criterion for our AppSec program? We need to know that. What are the KPIs? Do we need to hit certain compliance targets like Chris touched on? What about the norms and standards for our particular industry? We need goals. We need to know what success criterion is for this AppSec program. And then we need to identify those potential risks and then score them based on overall likelihood. How realistic is this? And then we can go about inventorying those assets. That's the threat modeling piece. Servers, databases, data flows. And then by doing that, we can identify those potential weak spots in our systems and then develop remediation plans. And then also, how do we educate and include secure coding in our daily development efforts? That we need to figure out how to do that. And then with tooling, we're talking about things like, on the one hand, we've got a number of vulnerability scanners available to us. We got SAST and SCA, which we'll talk about in a bit. And these help us uncover and tackle vulnerabilities ahead of deployment. And then we have tools that protect and monitor the apps once we're in production against runtime attacks. So that's code obfuscation, preventing reverse engineering, hardening. RASP, runtime application self-protection, things like tamper detection, defense. WAF, our web application firewall, that's protecting our endpoints against SQL injection live. If a SQL injection vulnerability does happen to slip through the cracks, well, that's where the web application firewall comes in. And then SIM and XDR, monitoring those endpoints. And when we think we have everything just right, we have penetration testers or pen testers that provide some sort of external validation of those security practices. So that could be external to our team or external to our organization, doesn't really matter, but pen testers will attempt to infiltrate our system in order to evaluate those security measures and then provide a specific recommendation based on their findings. So it's always good to have that external view. So this is DevSecOps at a glance. So maybe your organization does things differently. Maybe you got bug bounties, maybe you got red team, blue team exercises, maybe your vendor onboarding is more in-depth or rigorous, but overall, DevSecOps is about orchestrating these people, process, and tooling in all phases of the development process, so that we're not slowing down progress, and then we're still delivering secure apps in those potentially shippable increments, and providing defense in depth. We're not, like Chris was mentioning, we're not waiting until the tail end to provide that security stamp and then go get all the certificates, and we've thought about that well in advance. If you're relatively new to application security, or even if you're not, OWASP is an essential resource for all of our application development teams. The Open Worldwide Application Security Project is a not-for-profit that provides guidance for creating secure software. OWASP periodically publishes the OWASP Top 10 for application security risks. They got one for web, they got one for mobile, they got one for APIs. So they're curating and researching, and then they provide this as a resource to the community. And they're also providing documentations, best practices, and they've been a trusted resource for over 20 years. So I encourage anybody who's interested to not only take from OWASP, but also contribute back in your given capacity. All right, so with people and process, we come together to establish goals and those success criterion for our AppSec program. We can understand and quantify risk. So are we worried about a nation state attack? Are we worried about hacktivists? Or, are we worried about stealing of IP and trade secrets, reverse engineering, data breach, DDoS? Actually, just coming together, having a discussion about knowing your industry. Are we selling candy? Or are we working on a government agency website? All this stuff factors into how we apply security to our organization. It all does, every single detail. And then based on this information, and again, with the threat modeling, do we have a mobile app? Do we have a web? Do we have mobile, web, and desktop? Do we have a bunch of APIs that we've exposed? That's the threat modeling piece. Just from these, we can develop mitigation strategies and identify necessary security controls. It doesn't have to be super elaborate. We can whiteboard this stuff. We can put it in spreadsheets, but it's just about putting that thought into these ideas. Secure coding in the day-to-day, it eliminates many security vulnerabilities even before they occur. Configuring a sane lockout policy prevents a brute force attack. Sanitizing our inputs prevents SQL injection. So with just people and process, these people and process is critical. But a successful AppSec program is not possible without proper tooling. So there's tens of thousands of known software vulnerabilities, and they grow each year. We were dealing with maybe 1,000 new CVEs or CWEs, maybe 10, 15 years ago. Now we're dealing with 20,000, 40,000 each year that come in. So it's really unrealistic for us to think that we can manually uncover all these flaws, no matter how careful, no matter how diligent we are. We need that tooling. Static application security testing helps us to analyze the source code for security vulnerabilities before it's compiled. So SaaS can integrate into any existing CI/CD. We can add security gates, so we can pass or fail builds based on acceptance criteria for security, and that is configurable. And then we could also prioritize security by severity, impact, and likelihood. Another critical tool for our AppSec toolbox is SCA, that's software composition analysis. So that identifies and manages risk from open source and third-party components, also known as our software supply chain. As much as 80% of the software that we're deploying, we're packaging and deploying. So as much as 80% of that software is comprised of third-party components. So if we're just scanning our own source code, that's only part of the picture. So SCA helps us identify obsolescence. So that's how out of date this component is. So there could be bugs in this outdated component. There could be a lack of latest platform support. Have we moved to .NET Core and this is still only supporting .NET Framework? There's obsolescence risk and how out of date it is. There's obviously the security risk. So we discover vulnerabilities in these third-party components and they get reported. So SCA helps us identify those, and it works in broad platform. License risk. So there's risk in these third-party license agreements. So for example, copyleft licenses allow you to use a component in your application, go ahead and use it for free. But once you've done so, your whole application becomes copyleft licensed, meaning that you've open sourced your whole application or even a component of the application. Maybe the way the API uses it, okay, well, that's effectively open source based on the license agreement. So just as a result of these dependencies, we need to understand that risk as well.
Awesome. Yeah, really great stuff, John. And I think security plays a really large part, not just in testing, but this overall concept of TSDD. So I want to kind of bring everything together of what John mentioned and a lot of the topics on the test side, in addition to some of the challenges that we talked about with kind of this concept. So TSDD overall, right? What does this really mean now that we know, again, about a lot of the security aspects of it? We talked a lot about the test side, and I gave my example about a REST-based service. And John went through his piece as well. And we know some of the challenges with release agility and what teams want to really do, and really where they want to go. So TSDD, in this definition that we're kind of thinking about for our context, is really testing and security requirements that are defined and really even executed before development begins, ensuring functionality and security are really built into the software or the product that you're working on from the start. And this is really core to everything we mentioned. We talk about tooling. We obviously have under the Sembi brand TestRail for really everything you need for software test management, integrations, testing tools, and frameworks. And obviously Kiuwan from really a SaaS-based security product to really lock in all those concepts and really be proactive for all the items that John talked about in his piece. So that's really what we're talking about now when we talk and mention about TSDD and how we got here. So what does this really mean? And how can we kind of pull these concepts to kind of get it framed so we can start putting these things into practice? Test-driven development really can be focused toward not just functional testing, not just unit testing, but used around known security patterns and vulnerabilities in attack vectors to identify these issues early, just like broken access controls, and really adopt a shift-left approach, thinking about security. If we have services that use expired credentials, invalid credentials, or we can toggle certain access controls to exploit or expose information that is not desirable. Can we do that early, and can we do that prior to changes even being made? Can we factor that into our strategy? And really framing testing as an asset rather than a liability. Using it early to identify the state change of failed tests that we created before the changes, then transitioning to past, instead of something that holds our release up, it kind of moves it forward. John, I'll give it to you for SaaS and our security practices. I know you have a lot of good things here.
Oh, thanks. Thanks, Chris. Yeah. So just in terms of bringing it all together, just to kind of reiterate, we understand that the demands for faster time to production. So we're, nowadays, instead of releasing once a quarter, instead of releasing 2 times a year, we're releasing in some cases multiple times per day. If we have cloud native apps, and this is the demands of faster time to production can never be at the expense of security. So this is how it all comes together. So what we're doing in our day to day, we talked about the people, process, and tooling, and everything that's involved in securing these applications. Now, within the scope of your day to day, you might not be directly responsible for compliance, for log monitoring, for legal and PR and all these things that go around ensuring that we're delivering secure applications and protecting the organizations and protecting that data, that the customer data that we're warehousing. And that's really ultimate confidentiality, integrity of data, and availability. Nevertheless, we're all critically involved. And with SaaS and the security practices that we talked about, we can identify those vulnerabilities early, we can fix the vulnerabilities, and then we can maintain continuous security throughout the process. And yeah, so again, can't say it enough that everybody is critically involved in ensuring that our organization stays secure, the data stays secure, and we're not one of those companies that's in the headlines for a data breach type of deal.
Really great stuff, John. So I think that really rounds out pulling together this concept of TSDD and talks about not just testing, not just security, but the concepts of both, and using them to, propel our fast flow, looking at, program increments and how all this gains momentum and release agility. I think it's so important. So we do this with all of our webinars. For those of you that are returning for this one, for those that are new, we try to focus on continuous improvement to have something that's really actionable where you can take back to your teams or focus on concepts rather than just being something more informational. So every team is really different, but there's some definite factors that I think can make a difference around quality testing and security practices earlier in the SDLC, regardless of really what you're doing. One of which here is, early test creation. If you can write tests before code or the changes are implemented, knowing that they're going to fail in a valid and meaningful way, and we can go and actually target those for not just functional, but also security concerns and requirements, we're going to be way ahead on how we can actually catch these as changes start to roll in through either our defined PI, sprints, maybe a hybrid waterfall or phase gate approach. This is really critical. This concept next is really around automated early SAS scanning. And John, I don't know if you want to talk a little bit about the importance of really doing this from a continuous improvement perspective.
Yeah, sure. Yeah. I mean, just to piggyback of what you started with is like every team is different and every organization is different and everybody's different in terms of the interconnectedness of their testing and security teams. And we, in some organizations, we have dedicated, red team, blue teams. We have dedicated security teams. Oftentimes we do not. And so, regardless, with SAS scanning and continuous security feedback, we're continuously improving our code quality and code security over time. And that's the idea, is that SAS helps not only with identifying those vulnerabilities, but also really educating the team. Like maybe, we take for granted that not everybody is necessarily a security expert, just like everybody in security has not necessarily come from software engineering. The same way is true. So what SAS does is it not just, hey, here's a vulnerability and here's how to fix it. Over time, we're educating the teams. And then as far as security and continuous security feedback, just to kind of route it out, we also understand that not all risk can be totally eliminated. And so wanted to mention that post-deployment, we do still have to be aware of things like reverse engineering, tampering, theft of IP, trade secrets, and software piracy. So we do all we can by shifting left, but these other risks can be managed. And this is where obfuscation, app hardening, RASP, runtime application self-protection, and app shielding can be added as effective mitigating controls, just as a coda. So I think with the right people, process, tooling, and we can provide that defense in depth and prevent bad actors from undoing your good work.
Yeah, all great points, Sean. And I think really just to summarize, early test creation and getting this stuff running, ideally in a DevOps, or in this case, DevSecOps environment, and getting those tests running, early SAS scanning, and really just this continuous security and really feedback mechanism. These are really key areas for success and really pillars for good, agile, on-time releases and really help your teams move forward. So all great points.
Awesome. And wow, thanks for such an insightful session, Chris and John. And if you do have some further questions, we have contacts on both TestRail, Preemptive, and Kiuwan. And with that, thank you for spending your Thursday with us, and we hope to see you all again soon. Bye.